wear Cat 2 clothing all the time. If you work in and around energized equipment as part of your job description, wear a baseline of protection all the time. As far as mitigating injury, first, not catching fire versus catching fire. How many seconds before you get that garment off, or a colleague gets it off, or gets an extinguisher on you? If you had a baseline of arc-rated clothing, which weighs the same, looks the same, feels the same as your non-FR cotton that you were wearing that caught fire, if you're wearing that, you're not on fire.
So welcome everybody. This is the Electrical Safety Podcast. I'm your host, John Travis. Today I'm speaking with Derek Sang from Bulwark. Derek, thanks for coming on the show.
John, thanks for having me.
Yeah, no, it's a pleasure. And I think we were just kind of warming up here, having a little conversation. There's lots of really cool stuff we can go over, but just to kind of get us going, I always ask everybody, just so kind of the audience knows what's going on. It's like, you know, what's your background? How'd you get into what you're doing today, and what is it exactly that you're doing today? So,
well, my title today is Senior Technical Training Manager, Bulwark Protective Apparel. And as I tell folks, that's just a long-winded way of saying I don't sell nothing. I don't have a sales agenda. I'm not attached to sales. But how did I get here? Gosh, you know what? There is no degree program. There is no academic path to end up in our unique industry. Let's just keep it at that. My background, believe it or not, that I've never spent a single day in is public administration. I got into sales back in the day via copiers, like a lot of B2B folks are. Transitioned to there for in 12 years in the industrial uniform rental market. Ended up specializing in FR clothing at the time. Now, this is going back to 2004 for me. My first FR exposure was like 1995, when you had two choices. It was Nomex or it was FR cottons. And obviously we've come a long way in those 30 plus years. So then I transitioned through a couple of roles on the fabric side and then into the garment side, where I am with Bulwark. And my role today is I train either virtually, kind of like we are today. I do a lot of webinars, but then primarily focus on face-to-face with our end user customers, working on proper selection, getting good stuff, use, make sure you wear it right. And then this stuff's not cheap, so care for it, maintain it, because as I tell folks, we build life-saving pieces of equipment that just happen to look like shirts, pants, and coveralls. But if you haven't taken care of it and you didn't start out with good stuff properly, it's not going to do its best job when you need it the most. So that's kind of where I am today, and been doing it now 25 plus years, believe it or not.
Wow. No, and that, so I guess just for clarification, I mean, you mentioned FR, and I know in the last 5 to 10 years, they've also started talking about AR. Is that something that you guys are also involved in? And maybe could you explain the difference between the two?
Sure. Really, the difference is NFPA 70E came out in 2012-ish, 2015-ish editions, and said, we need to clarify for our electrical folks what exactly we mean by FR. And so they wanted you to wear arc-rated clothing. All arc-rated is flame-resistant fabrics that went through additional testing to let you know that they can protect you in that incident. So anytime that you see an ATPV or an ESUB-BT or that little 8.6 calories per centimeter squared, that tells you that that fabric has went through the appropriate testing in order to achieve an arc rating. Hence, it's arc rated. So the easiest way to think about it is all arc-rated clothing, by definition, first and foremost, has to be flame-resistant. All flame-resistant clothing does not necessarily go all of the additional testing to ultimately be arc-rated. So that's why the committee at the time wanted our electrical folks make proper decisions, so they helped to clarify it.
Okay. And then something that I've always, so you mentioned like the fabric, and we were talking a little bit about this before too, but like something that I know, like for the end user, you know, there's different companies out there, obviously at different stages of the game here. So how does it work? And when they're trying to figure out what they need for arc rated clothing, like where, you know, just kind of, can you give us a landscape a little bit on how the industry works, like how the FR/AR clothing industry fits together?
So first and foremost, you're absolutely right. We don't make it easy for you. In fact, the visual that we use is a lineman on a pole and just a snake's nest full of lines all interweaving the worst case scenario you can think of in an electrical environment. And that's how you have to make your choice, because we don't help. We have sales folks calling on, if you're a major end user that uses our garments, you're going to have fabric folks calling on you. You're going to have distributors calling on you. You're going to have different service mechanisms from industrial laundries all the way through. And every one of them has a solution. So, for example, Bulwark Protective Apparel exclusively goes through distribution for the most part. That we have about 4,000 distributors. So I have sales folks that are saying, hey, spec our stuff. You spec our stuff, then I have to get you in contact with a distributor. You have distributors coming in and going, doesn't matter what you spec, I can get you anything you want, just go with us. So it's a multi-layered decision process. So you want to look at the mechanism on how to get it to your people, whether you're directly buying it and it's getting drop shipped, or you're having a third party drop it off and pick up dirties and doing like a service side of it. Or you're going online and you have a choice program to where they've custom built a catalog for you, and you have a variety of different solutions in there that they've approved of from, again, multiple different manufacturers. So if you're looking to do this and do it right, you can have wear tests from all my competitors in there. You can have multiple folks bidding for how to service it. So it's not easy. So the one thing that we try to coach for, and it doesn't matter who it is, find someone that you trust, find someone that you have a dialogue with, and someone that's going to help you walk through the process. Because first and foremost, safety folks today are, how many responsibilities do you have? And in all honesty, how far is clothing down the line? I mean, in reality, with all the other things that you have to worry about.
Mm-hmm.
So you want to get that box checked off as efficiently as you can. So in order to do that, kind of find someone who can be, that doesn't necessarily have to be a consultant, just someone that can guide you through it. Talk to some of your other safety folks when you do get together and what they did and how they learned and all those things. So not that most concise answer, obviously, and not the one to where, oh, I'm going to run out and do that, because it is not easy, because the landscape is so varied. But there are distributor partners, there are manufacturers who have influence and everything that way. So,
well, let's imagine I'm working at a pulp and paper plant and I get a call, and you mentioned you might get a call from one of the fabric companies. Okay. Is that even true? Like, did I get that?
Yes, absolutely.
Okay, so
all our top fabric folks today have business development managers who are in the field, and their goal is to get their fabric spec'd.
Right.
Once you say, for example, Endura Ultrasoft by Westex, that's the easiest to think of, very common brand name through, everybody's either used it or at least heard of it.
Right.
They have sales reps that are in the field whose goal is to, in that specification, when you go out to bid or an RFQ or an RF, whatever you want to call it, they said Endura Ultrasoft shirts, pants, jeans, whatever the case may be. Then you're going to have someone on the manufacturer side say, I can do that. So you're going to have folks come in from Ariat, from Rasco, from Lapco, from Lakeland, from us, who are then all going to give you their version that's made of this fabric. Then you're going to pick one of those. Then they're going to go, well, I have Tyndale, I have Cintas, I have Port West. I have a variety of other folks that you can then ultimately, that's where your PO is going to go.
Right.
So again, just even in our short time here, I don't know if you're any more clear on how all that happens, because that's how convoluted it is.
Yeah, no, but that's what I was getting at. So let's keep going here. So if, so let's say that I'm going to go to Tyndale. You said that as someone who I could cut the PO for.
Mm-hmm.
But what you're saying is that I could spec almost whatever I want. I want this fabric. It's got, like, I can kind of give them those specifications. It's not just as easy as maybe going but I'm sure you guys try to make it easier and give them some options, give them a
So
catalog.
obviously our bias is with our breadth and our width of our product, we think we can satisfy everybody's potential needs, whether that's jackets, hoodies, sweatshirts, button downs, jeans, pants, cargo pants, whatever. We feel that we can do that.
Mm-hmm.
The truth is you're not going to hit every category 100% of the time. And just like you and I, when we go to a retail store, I could bring in 10 people, take them into your favorite retail store, and we're all going to come back with a shopping cart full of some stuff that's similar, but we're all going to have our nuance. And that's where evaluating that mechanism that ultimately gets there. How deep and wide is their store? What choices can they provide your folks? Because at the end of the day, it's a lot easier to be compliant when we want to wear it.
Right. Yeah. Okay. So let's go back to the fabric. Let's clarify a few things. So first you said everything AR is going to start out as FR.
Correct.
So in order to be FR, it's got to meet, what standard does it have to meet to be FR?
So baseline, we start out with ASTM 6413, the vertical flame test.
Okay.
It has to put itself out 2 seconds or less of after flame, and it has to have a certain amount of char length, 4 to 6 inches, depending on what standard, and it has to have some resistance to tearing. So that tells you that it's got a baseline, because fundamentally, and the easiest way without getting too complicated is all flame resistant by definition puts itself out once the ignition source is gone. So whether that's a 6-cycle arc flash or whether that's a 2.5 second petrochemical flash fire, at the end of that event, that fabric has self-extinguished, regardless of the technology of how or the engineering that it got it there. The engineering can happen in 3 different ways. Molecular level. We all know who that is, even though everybody goes, well, what does that mean? I take nylon, I tweak its molecular formula, it can't sustain combustion. Guess what I got? I got Nomex. FR motocrylic. Well, in order to have FR motocrylics, and I had non-FR motocrylics, so what did I do? I took a whole bunch of fire retardant chemistry, I poured it into that soup, I extruded a fiber, now I have a flame-resistant fiber. So I have an FR fiber. Then we take fuel, aka cotton, and I put it through a process where I bond phosphorus and nitrogen to that cellulosic. Well, it doesn't burn, it actually chars, so it self-extinguishes. Those 3 engineering methods can be used in any combination. I can combine them with non-FR fibers to ultimately create a fabric that will put itself out once the ignition source is gone. So we evaluate that primarily. 6413 starts the process. Then I have to go into additional thermal shrinkage, strength tests, other tests for different standards. So when we look at like 1506 and when we look at 2112 for a flash fire, they are giving us the guidelines in which to meet to ultimately, when we produce a garment, okay, we've gone from fabric, now findings, all the stuff that goes into making it a garment. Then we go to facilities, all the construction processes that go into that, make sure the threads are FR, make sure all these things. So I tell you all that to say that's why we want to use proven supply chain partners that do everything right, because think of all those processes, and I can take shortcuts to give you a less expensive version of a good version. That's where we have to be cautious of. So as we take people through this exploration and this journey to understand ultimately what to specify, it's more than just going in and going, okay, that standard, that arc rating, this, that, and the other thing. Why? Because those in and of themselves happened in a vacuum, meaning that I satisfied a test methodology with a piece of fabric. You wear garments, you don't wear fabric. So you have to take the dialogue into that whole safety message, because I can have, if I go in and I look to from a pure spec standpoint, and I meet all the standards in fabric A, and I meet all the standards in fabric B, and then I produce garment C and garment D. So now I have 2 garments. Well, one garment's $50 and one garment's $120. What's the difference? The difference you'll find out is the day you need not to find out the difference.
Mm-hmm.
Because in economies of scale and how everything works, there's not going to be that much variance when you're building something properly. So when you start looking at ways to produce a less or more economically friendly version of something that's good, you've had to make some of those shortcuts. So when you ask, what are the test methods? I'm not a huge standards guy, test methodology guy, because pretty much it doesn't take a lot to meet that baseline to get into the market. Our standards are great. It's fantastic. We have at least a jumping off point.
Yep.
But they're designed to be inclusive, not really exclusive. They're designed to get okay, here's the ante. Okay, everybody's around the table. Everybody ante up your $5. Well, the ante's nice, but how big of a pod do you have to sustain this? Well, if I'm anteing up $5 and I've only got $20, I just put in 25% of my resources versus things. How long can I stay in the game?
Right.
So there are baselines that you need to satisfy. Trust that 99% of the people that we're going to even bring up in conversation or that you've ever talked to meet or exceed all those, because they're not that difficult to do.
Okay. Yeah. Well, and that's, I mean, where this question was even coming from. And, you know, I'm just thinking back to a few of the sites that I've come across over the years. We get into the conversation about PPE, and they're not even wearing the ARC rated stuff. So, you know, to think that they went through an entire procurement process to figure this out and got that far off the mark, that not only didn't they, I mean, maybe they got the FR stuff. That's probably usually where they end up, but then they didn't even realize that there's this other testing they've got to go through to get to the AR. And then, yeah, I guess maybe going from here, we should shift over to some stuff that I think there's a lot of questions that just come up all the time for people. Like one of them that you might get is, you know, whether or not, so you've got like the AR, let's say AR shirt and pants, and it's cold outside. So you want to throw on like a cotton overcoat. Like, what should people know about that, or how should they look at that kind of stuff?
So when you look at fundamentally, and I'll go back a little bit and then bring the journey forward. We look at NFPA 70, look at Z462, and think of how long it's been in the marketplace now, almost a quarter century. Why are we still having electrical workers hurt by arc flashes? Well, you just described one scenario, and really it boils down to one of four. I don't have it. I have it and refuse to wear it. I have it and don't wear it right. Or I think it's de-energized. And it's not, because I failed to verify. So I've doffed my PPE because we got to get this stuff off. It's so, cumbersome and hot, and I just need to get out of it. So whatever I have to do to get out of it, let's go do this stuff. So to your point, that falls into one of the areas to where when we talk about, let's say, for example, especially in some of our colder climates, I've got my very expensive brown duck 40 cal ARC rated winter coat. And it's a little bit colder today than it was yesterday. Why? Because I checked my weather app. It says it is minus 20, and that was colder than it was yesterday. So I grabbed my gray hoodie off the back of the door, put it over top of my arc ray shirt, then put my big brown duck coat over top of it, because now I'm going to be a little bit warmer. I have no idea. Well, I know that that's a non-FR gray hoodie, but I've got my big coat on over top of it, so I'm pretty good to go. So here we go through the workday. What's the one thing they tell you when you start sweating in the cold is don't sweat in the cold. So you're going to start doffing your outer layers. Well, now I take that big brown duck coat off, and I forget that I'm wearing, my retail gray hoodie underneath, and I'm now in the minimal approach distance, the arc flash boundary, whatever the case may be, and there's an incident. Now I've got a huge cotton fire on top of my FR arc rated clothing, which completely nullifies that. You may as well not be wearing anything, because remember, that only works when the ignition source is removed. If I have 400-degree burning cotton on top of me, that ignition source is going to be there until it burns off or someone puts me out.
Yeah.
So the 4, 5, 6, 60 seconds, 90 seconds that's burning on me, my FR clothing is ineffective. In fact, under those conditions, your FR clothing is going to begin to fail. It's slowly going to open up, and you're going to be exposed to all that injury as if you never wore it.
Mm-hmm.
So I know that wasn't your direct question, but I think we got there, right?
Yeah, definitely. And then actually that makes me think of another thing. So, I was always under the impression that, an arc flash happens and you've got 10 different hazards kind of coming at you at once. When we're looking at the label that says, 9 calories per centimeter squared, that's the incident energy. That is a heat energy. That's different than the flame. So can you explain that a little bit, or
Sure.
correct me if I'm wrong? Like, how does that, what's the difference
So
between flame and the incident energy? Yeah.
So incident energy and arc ratings are both measured in calories per centimeter squared. It's just a measurement of heat, regardless of how we get there.
Mm-hmm.
So and that's why your arc flash study is so important, because as an electrician, I now walk up to a piece of gear and I know, because it's labeled correctly, exactly how much incident energy can come out of that if it fails at 18 inches.
Mm-hmm.
Let's guess. So I look at that, and let's say that's 5 calories per centimeter squared. I'm wearing my Cat 2 8-cal shirt. I am good to go. Why? This will protect and insulate up to 8 calories. That's what it has been tested for. So it's been tested to resist break open. It's been tested to insulate. It's been tested to do all those things. And then at the end of the day, I throw that magic Stoll curve up there and I say a 50% probability of a second-degree burn. That's what our arc rating is. In reality, under those conditions, a 5-cal arc and an 8-cal shirt, zero injury underneath that fabric. So that's why that understanding what the incident energy is important for me to insulate and protect to. Assuming that the ignition source, hence removed, either the circuit breaker kicked in, the fuse kicked in, whatever happened, that electrical equipment recognized there's an arcing fault, boom, and shut itself off. That 6-cycle exposure produced 5 calories of energy. I'm wearing an 8-cal shirt. I've got a big char spot on my chest. I'm breathing rapidly. I'm in panic mode, but everything is, injury is mitigated.
Mm-hmm.
And that's all in the most elementary way possible. That's all it does. So with that, what about when I superheat the air in that arc gap to 35,000 degrees and I vaporize copper? And that copper resolidifies in open air at 5,000 times its original size. And it's 1,900 degrees because it's molten. And then I'm going to fire it at you 750 miles an hour because I have created a bomb inside that little gray box. Well, that's why we have hard hats, and that's why we have face shields, and that's why we have balaclavas, and that's why we have rubbers and leathers, because the other thing that a lot of electrical folks, not that they forget, they just fundamentally just don't think about, because that arc rating, that 5 cals is at 18 inches. That's the shiny parts to my chest.
Mm-hmm.
Where are these magical machines? They're a heck of a lot closer than that. So when I see someone wearing their arc rated shirt and they start doing this because they can't pick something up or they need additional dexterity, and you put that in the box, how many calories are these exposed to?
Mm.
And when we start evaluating burn injury, burn is just a measurement of depth. So when I have 1st degree, it's on the surface. 2nd degree, I'm getting a little bit below. 3rd degree, I can't even hold my fingers so that you can see them. That's even too thick for 3rd degree. And you've lost your ability to regenerate. How much flesh and tissue and muscle or flesh and tissue do you have before I'm into muscle and bone on these magic? You don't have a lot to sacrifice.
Mm.
So when you end up in a burn unit and you are mitigated your injury because you're wearing your arc-rated clothing, but you doffed your gloves, your career is over, because when you get into muscle and bone, that tissue's dead. They're removing digits. They're removing parts of your palm. They're removing next to your brain as an electrical worker. This is the second most important tools you have. Without these, you don't work. So when I start removing digits, that's a career-ending injury. And you imagine doing everything right. Imagine having all the PPE and then shaking these puppies off, putting them in the bag because you want to pick up a screw.
Yeah.
You know?
So, okay. So then that got me thinking about something else. So you mentioned, we'll just repeat that again so first degree, second degree, third degree, and were you saying like the thickness of?
Yeah. So
As
when everybody's heard the terms first degree, second degree, third degree, we measure burns in two ways: extent and severity. Extent is how deep it got. Severity is how much of you got gotten.
Right.
So when we do our total burn assessments and we do the rule of nines, that is extent. So when I say 25% body burn, 30% body burn, that's how much of you got gotten.
Right.
And we only measure second and third because why? First degree heals on its own, no medical intervention. Second degree is the onset of a blister. Okay. We worry about blisters because they're going to break and that's a pathway to infection.
Okay.
Third degree, I no longer have the ability to regenerate on my own. And I'm going to have to go to a special facility in a hospital called a burn unit because now I'm going to have skin grafts. And if there's enough of me to harvest, meaning I've got enough of me left over, I want to use my own skin first. I want to use cadaver skin and donor skin second. We get all the way down the line. I don't have enough of that. In some of our severe cases, we can actually use pig skin, believe it or not. It is compatible for a short duration.
Wow.
And when we're talking literally into the epidermis to where we're starting to get through that, when you go and Google skin layers, it is so small or so thin a layer before you can no longer regenerate. You've lost your nerves, you've lost your sweat glands, all that stuff is on the surface. So when we look at these prolonged rehab and rehabilitation and recuperation for our burn victims, that's why, because whatever skin I'm putting on them no longer sweats. Nerve endings will come back slowly, but there's a lot of numbness in those areas because it doesn't come back the same. When you talk to some of the folks you've talked to who have been arc flash survivors, they are far more experts on this kind of recovery, but it does not take a lot. And when you look at, and you could just look at the top of your hand and just try to pinch some skin off there versus around your belly. How much skin do you have to sacrifice here versus a love handle? Not a whole heck of a lot. And when that is inside the box, even though our reptilian Cro-Magnon brain flinch response when that arc happens, I'm getting these out of the way pretty quick. That being said, that's still a lot. You'll see, and you've seen and talked to these folks who've had their hand injuries. You see the degloving that starts to happen where literally skin is shuffling off just like if it was a glove.
Yeah.
If you get into third degree on that machine is not going to be able to work any longer.
Is there like I know in the standards it says 1.2 is the onset of a second degree. Is there anything for third degree? Is there a number that people have kind of figured out that, you get into working on something that has an arc flash level of, I don't know, even like 3 or 4 or 8? Have you heard anything like?
Yeah, I understand what you're saying. How many cows? So when Alice Stoll started messing around and created the Stoll curve, that was to the onset of a second degree burn, which is a blister, because we know once we start damaging the epidermis to that spot, anything, all it is time, and all it is heat and heat over time. So you can see all the graphs where they talk about like your hand in boiling water. Mm-hmm. How many seconds do you have to a third degree burn? There is tons of studies out there that will give you, under these conditions, under this circumstances, how many seconds or fractions of a second to a burn or the onset of a burn or a third degree burn. And the reason that we have arc rated clothing designated at that calorie level is because anything above that is going to be, that's more heat over time, greater injury. Mm-hmm. So if I don't want to be injured, I want to wear my PPE. Well, we're telling you that 1.2 calories of energy will produce a blister. So anything above that's going to be worse. when people ask us the question, well, how do you think of that without, okay, back in the old days, big lighters. And I take a big lighter, preferably hold a friend's finger, not your own,
Mm-hmm.
over top of that flame for 1 second. You'll get a little brown spot. That little brown spot is a blister. So 1 calorie of energy for 1 second will cause a blister. When we're looking at 8,000 degrees in a fraction of a second being delivered to that flash burn
Mm-hmm.
is pretty instantaneous. It's not, and then not to complicate it further, but when you talk to our trauma nurses, when we talk to our burn nurses, once that hits, it doesn't stop cooking. This may be a little weird or a little uncomfortable for some folks, but think about that steak that you throw on the barbecue and you hear that sizzle. You take it off the barbecue, it doesn't stop cooking just because you took it off the barbecue. When I'm transporting you from the incident 20 minutes down the road to the ER, another timeline in to get you things, that is continuing to cook.
Mm.
So even though those flash burns on the surface, you'll see people like when you talk to Jason and when you talk to Brandon, they were still talking.
Yeah.
They were still in communication. Why? You flash through those nerve endings. They're not necessarily feeling pain. They know they're hurt. They just don't know how badly. But when they get into the burn unit, that's when you see them all wrapped up. You see them get put into, not necessarily in those kinds of cases, but you see them get put into drug-induced comas. You see them to get in there to mitigate some of this stuff because all that damage just does not stop because I get you to the ambulance and or to the hospital and or to the burn center. So there's a lot of things. I mean, burns are just absolutely nasty. Arguably the worst or second worst thing that can happen to the human body because they're just, you can go in and think that you've got a small, I'm okay, it's just here.
Yeah.
And, 4 days later, you don't have an arm.
Yeah. So maybe a good way to look at it then is just once it goes above 1.2, it's just going to get worse and worse.
That's why when we look at it fundamentally, and I know this is easy for the arc flash clothing manufacturer guy to say, fundamentally and baseline, and you can go through all your standards, all your rules, all your regulations, all your electrical safe work practices. What we want folks to think, wear something all the time. Wear Cat 2 clothing all the time. If you work in and around energized equipment as part of your job description, wear a baseline of protection all the time. Because, as far as mitigating injury, first, not catching fire versus catching fire. You asked, how long does it take? Well, think about it. Non-FR cotton burns at 400 degrees. That's 2 to 3 seconds to a 3rd degree burn. You can't get it off you fast enough not to be burned. And then think about it. How incapacitated are you after one of these events? You're disoriented at a bare minimum, aka what just happened to me?
Mm-hmm.
How many seconds before you even realize you're on fire? How many seconds before you get that garment off or a colleague gets it off or gets an extinguisher on you? Let's say it's 10 seconds. Well, if it's 2 to 3 seconds to get 2nd and 3rd degree burns at 10 seconds, how much of you is being burned that didn't have to be? And by saying didn't have to be, if you had a baseline of arc rated clothing, which weighs the same, looks the same, feels the same as your non-FR cotton that you were wearing that caught fire, if you're wearing that, you're not on fire. So when we say about mitigating injury, when we talk about saving lives, when we talk about the fact that an electrical worker wearing their flame-resistant arc-rated clothing properly in an arc flash event will not be a fatality. Will not be a fatality. I can't hurt enough of you because you do not catch fire. The only way that I hurt enough of you for you to ultimately end up being a statistic, aka a fatality, is for you to catch fire and continue to burn.
Mm-hmm.
So fundamentally, if I don't have to make a decision, aka bring my kit with me, aka take off my boots, put my coverall on and do all those things, if I'm just wearing it already, if my jeans and my shirt already are arc rated, what's the chance of me being hurt enough to ultimately be a fatality? Yeah, I can still do a lot of dumb stuff. I can not wear my hard hat and face shield. I can get some facial burns. I could lose my vision. I could lose some digits because I'm not wearing my rubbers and my leathers. But am I a fatality? Can't hurt enough of you to do it. And that's why we preach all day, every day, a baseline of protection, wear your Cat 2 daily wear. And then if you have to get into a 40 cal suit to do some switching, or if you're on some big breakers, or you're working on an electrical room where you're a little bit confined space, you want the, by all means, use that to enhance and complement your daily wear. But get away from wearing fuel in and around ignition sources. Because I ask electricians all the time, answer me this question. Do you wear arc-rated clothing to protect against arc flashes? Is that the hazard? Yes or no? True or false? Fact or fiction? Whatever way you want to term it. And everybody goes, yeah, absolutely. And it's false. We don't wear arc-rated clothing to protect against arc flashes. We wear it to protect against clothing ignition. Clothing ignition is the hazard. Arc flash is just the ignition source. So when you look at the fire triangle, you've got ignition source, you've got oxygen. Well, the ignition source just happened. Okay, the arcing fault's there. Can't do anything about the oxygen in the air, Bob. Sorry. So what's the only thing that you can control? Fuel. Don't wear fuel into an ignition source. Plain and simple. Take that out of the equation. How do you do that? Don't make any decisions during your workday. Have a baseline of protection. Have Cat 2 clothing, shirt and pant all day, every day.
So I had a client I was talking to who was they were thinking about doing this, and part of the group wanted to go to it, like a daily wear, let's say 8-calorie clothes.
Yep.
And the other, it was a manager or someone, was nervous that if they were wearing the clothing all the time, it would become compromised in some way, and wouldn't be effective, because there is information out there that says, oh, well, you have to, there's special ways to launder it. And he had a good point. My take on the situation was, you're, I would say, probably going to be safer more of the time if you do have the daily wear. But what would you say to him about those concerns with, the wear and tear or the laundering when it comes to daily wear?
Absolutely. It's not unfounded, but thankfully in today's modern fabrics, in today's modern garments, we've made it really, really hard for people to mess it up. In fact, probably, depending on the numbers you want to talk to, probably 60% of all FR arc-rated clothing wearers take their stuff home and wash them themselves. Why? Because it's pretty simple. The don'ts. Don't use bleach. Well, most of the stuff is colored anyways, and you're not going to use bleach on your navy shirt or your khaki shirt anyhow. So that's one. The other one is peroxide. Peroxide is a sneaky one. Why? Where do you find that? OxyClean. So don't have any liquid detergents that have the word oxy in it. No fabric softeners. Fabric softeners are an accelerant because they're petrochemical based. And no starches. Don't use anything that's going to get into or clog up any kind of FR response that you need. Wash it in hot water, tumble dry, you're good to go. So from a cleaning standpoint, that is easy. From a secondary accelerant standpoint, getting stuff on it during the workday, you have to be cautious. If you've got hydraulics on there, if you've got other kind of oils, if you've got any kind of secondary accelerant, you give it an ignition source, it could ignite and you could have a hot spot. But at the end of the day, that FR clothing is still going to give you less energy than if you're wearing a cotton shirt and you had accelerant on it and it caught fire. It's just going to be a bigger fire.
Yeah.
So I understand folks thinking that way. So fundamentally, you do want to train people, because now under 1910-132 for us, you in the US, you have to train people under PPA. Well, that includes now your clothing, when and where to wear it, how to take care of it, how to maintain it, how to repair it, all those things, whether it's a hard hat, safety glasses, gas monitor, all go through the same training. So now all you do is include clothing.
Yeah.
I'll be honest with you, the biggest pushback we get between daily wear and task-based is cost. It's going to be way cheaper for me to give a guy one coverall and a hot kit, and he drags that along.
Yeah.
Well, in theory, that sounds almost right. And you would think that if I'm going to buy a guy a $200 coverall versus $1,000 worth of shirts, pants, jackets, and everything else, is going to be cheaper. It is until you think about it this way. Let's say I'm an electrical contractor. I have 10 guys doing service work. Okay, they're out every day in their trucks carrying their hot kit around, and they're going to see our customers, and they're going to be doing voltage testing, troubleshooting, and verifying for lack in voltage, because they're our service guys. They're not new construction. They're actually working on our customers' electrical equipment, and they're being called out there to do PMs, troubleshoot, whatever the case may be. So I have 10 guys, and let's say I do 10 energized tasks per day per guy. Voltage testing, troubleshooting, and verifying. That's not unreasonable in a workday. That's 100 energized tasks. So my team is going to get in and out of their coveralls 100 times a day. I'm going to be very conservative. I'm going to say your guys are highly performing, super skilled, on the ball clothes changers. So they're going to get in and out of their coveralls 5 minutes in, 5 minutes out, 10 minutes per thing. That's 100. That's 1,000 minutes a day. Times, everybody works 24/7, 365 now, but I'll be conservative. Let's say I'll give you 25 days a month. That's 25,000 minutes. And you're paying an electrical worker what, $50 an hour? Do the math. It's literally tens of thousands of dollars a month in downtime changing in and out of one coverall. I take that all away by taking that $10,000 and buying all your guys $1,000 worth of PPE for 1 month. So instead of costing you $120,000 a year in soft costs that you're not thinking about, I'm going to do it one time for 10 grand. And then your people aren't getting in and out of anything. Yeah, they're putting on their hard hat, their balaclava, but they're doing that anyways. Yeah. No one's walking around with that stuff. So I can't save you money and time there, but I can save you money and time not getting in and out of the coverall. So when we look at the cost justifications for just that simple 10 main company, it doesn't make sense to put them into task-based. And then when you look at the number one reason people don't wear FR clothing, it's hot and uncomfortable, right? Well, what's a coverall? I'm putting it over top of my existing clothing. So is it going to be hotter? Well, yeah, I just added an additional layer. Is it going to be cumbersome? Yeah, coveralls are not designed to be ergonomically friendly. They're bulk items. They're clunky. So I just reinforced the two main reasons not to wear it. So when your people are out of sight and out of mind, what's the likelihood of them getting in and out of their coverall 10 times a day? So how much is your company compromised? Mm-hmm. And then imagine that I just spent all that money on 10 kits for my 10 guys, and God forbid someone got hurt. You're going to get all the same citations, all the same lawsuits, all the same problems as if you didn't do anything. So which one is more viable at the end of the day?
Well, that's an excellent point. I thought you said you weren't a salesman.
I'm not.
Yeah, no.
It's get home safe guy.
I want to be, we're kind of coming up on time here, but I wanted to ask you one more question at least.
Sure.
So I haven't followed exactly what Bulwark is doing, but I know a lot of companies out there, clothing, they're pitching like the 100 calorie or the 120 calorie suit. And that kind of, you know, there's still a lot of people I talk to in the industry who think that 40 calories is the cap. Mm-hmm. And so I'm just curious if you wanted to touch on, you know, even the history of the 40 calorie and why has that theory changed now all of a sudden? And, you know, what is this all about anyway?
Sure.
Yeah.
Can you protect people? Yes, you can. They build 120 cal suits. Myself, fundamentally being a non-electrical guy, not that I'm comfortable with 8 cals, 20 cals, or 30 cals, but man, if someone told me I needed to go and put on a 120 cal suit to go into equipment, I would like, there's got to be an easier way. Mm-hmm. That seems like a lot. But that being said, fundamentally, the gear is built to protect you. there used to be, and it's still in the marketplace, there's kind of like that urban myth so with an arc flash, you have an arc blast. They happen simultaneously. When you blow something up, you get concussive force. Okay. The bigger the bomb, the bigger the concussive force. Well, unfortunately, they're not linked linearly in the sense that the more incident energy you have, the bigger the explosion. Now, explosions do happen. The old myth or the fundamental thought was if I have to wear a 100 cal suit, the actual concussive force will turn me to jelly on the inside. It does not matter. That has been proven wrong many, many, many years ago. I grew up in the world where 40 cal was the top of the scale because anything after that was so dangerous you couldn't work on it. Well, as we learn more with anything else, that proved to be a fallacy, that proved to be incorrect. When we go and do open air tests at Kima Laboratories, for example, we'll put a arc flash suit on a mannequin. That mannequin weighs about 50 pounds, put on 20 pounds of gear. At the end of the day, it's less than 100 pounds. We'll mount it on a ladder. We'll put it in front of a big piece of equipment. And in that 40 cal suit, we'll get a 35 cal explosion. Suit works perfectly as you would expect. That ladder doesn't even rock. That mannequin may do this. So for us to correlate the arc blast as being so destructive we can't work in that area has been proven wrong now for probably close to 20 years at least. The problem is anytime you link something in urban myth, it's very, very hard to dislodge it. A lot of our folks who now are at the crescendo of their careers, they're in their 50s, they're going into their 60s. That's been their mantra, and that's what they grew up understanding, and that's kind of continuing through. So I say all that to say that, especially with our Canadians moving to 75, is that unreasonable? No. NFPAs literally didn't stop at 40 per se. Other than that's what the technology was at the time. That's what they understood at the time. That's where the vast majority of testing had been done. In fact, 70E, and I'm going to mess up the verbiage, as long as if you calculated and used the incident energy method and you had the appropriate PPE, aka a 65 cal potential incident energy, and I'm wearing a 70 cal suit, it's absolutely applicable. That being said, I still fall back onto anytime I see that much incident energy, I'm probably going to want to put that in electrical safe working condition. I'm probably going to want to reschedule. I probably want to go do something else. Now, I know there's folks in this that are going to listen to this and lose part of their thing. And you're going to have a big comment section saying this is, as long as I follow this and I've done my hazard assessment and I've done all these things, there's no reason in the world that I can't climb into a 100 cal suit. And understand that's their line of expertise and they've done the job too, and all to them. But yeah, that kind of just triple digits. We build it. Doesn't mean we should use it, I guess, is what I'm saying.
Yeah, no, it's it's definitely a hot topic, and people. That's why I asked you. Like, I'm just always kind of gathering data and seeing what everybody thinks of things. And yeah, certainly.
Well, there was a strong lobby up in Canada to get those changes made in Z462.
Yeah.
And we know who the folks and how that came about.
Yeah.
And can it be done? Sure. Do we have the technology? Sure. Should we be putting our electrical workers? And my thing is, if there's no alternative, then fine, go do it. But I think today there's a lot of alternatives to where we shouldn't have to put our electrical workers into that kind of gear to do their job.
Yeah. Oh, that's great. No, I think we're out of time. I want to thank you again, Derek, for coming on. If there's just quickly some, a place that if people want to reach out to find you, maybe you can just share that.
Sure. The easiest place is jump on LinkedIn. Easy to find. There's not too many Derek Sangs around there. If you want to connect, other than that, it's derek.sang@bulwark.com. Pretty easy also. But yeah, I have a brand bias, but if you have a question that's outside, don't think it has to be about Bulwark. Don't think it has to be about anything else. But if it's a clothing concern, yeah, definitely feel free to reach out and ask us. And John, thank you for the time. It went by real fast.
It
So
did.
I guess that's a good thing.
That's a good thing. Yeah. No, thanks a lot. Enjoyed it.
All right, bud.